Hello and welcome. London Packaging Week is proud to partner with Heidelberg for today's Sustainability and Automation webcast, exploring the two mega trends shaping the packaging industry. With us today, we have Kerstin Haase, Business Development Manager Packaging from Heidelberg, Germany, and Matt Rockley, Product Executive, Sheet Fed and Digital from Heidelberg UK.
Hello.
Heidelberg is a worldwide supplier for end-to-end solutions in the printing industry with a strong focus on packaging. Matt, can you give us a short insight into the UK market and to Heidelberg UK?
I can, yes. This year we've seen a sharp rise in sales and in customer interaction in all areas of packaging solutions, ranging from full MIS integration, which delivers a huge range of information providing the press with fully automated data. And after visiting one particular customer case this year, all of the information for a packaging job is delivered directly to the press, after being automatically processed from our pre-press workflow, meaning that the system is fully automated. And when we look towards the presses we have sold and taken orders for this year, packaging solutions are definitely on the up. There are around 40% of our machine sales this year have been towards packaging, including new customers to Heidelberg, those customers that have perhaps never seen Heidelberg equipment before, partly due to the automation advances that Heidelberg offer. So packaging is certainly a flourishing market and on the up.
So two topics that are currently on everyone's lips in the packaging industry is sustainability and automation. Can you confirm this and how does it affect Heidelberg?
Yes, of course. These are also key topics for our new product developments and innovations. And when it comes to sustainability, we see two things driving our customers, the packaging printers, and their customers. It's circular economy and recyclability of packaging and reducing the carbon footprint of packaging manufacturing, which is driven by the consumer. We see that consumers tend to prefer fiber-based packaging, such as folding cartons. This is also shown by a study on European consumer perception of packaging from May 2021. And it says almost 80% of respondents prefer packaging made of fiber-based material. And I think that speaks for itself.
Absolutely.
There's also a lot going on in the area of legislation, which is the key driver, such as the EU's Single Use of Plastic Directive, which aims to reduce the environmental impact of certain plastic products and includes, for example, polystyrene, food containers, beverage containers and cups. Or the UK plastic packaging tax on plastic packaging products. I mean, you are in the UK, so I think you have brought some examples.
Yeah, so the reduction in plastic has led to a growth in carton manufacture. So you can see punnets for tomatoes or for broccoli, for meat or fish products, where from a sustainability point of view, these products reduce the plastic content by up to 75%. So the consumer would have fish, meat products, and there's a description, of course, on the packaging itself. So what happens then is that the product is very easily recycled. So just 25% of this product now is plastic, goes into the bin, and then of course this is recycled. So there's a huge drive in all of the major supermarkets for all of these products to reduce the plastic content within the product.
Interesting. And this goes along the entire value chain. We, Heidelberg, are also experience a massive increase in inquiries from our customers on compliance or environmental topics. In 2018, we had 11 inquiries on environmental topics. In 2020, there were more than 170 inquiries.
Wow.
Yeah.
Okay, so on to the next question. Currently in Europe, including the UK, paper and cardboard packaging has already a recycling rate of nearly 85%. Heidelberg is a member in the Forever Green Alliance, and what is this about?
Okay, as one of the main technology providers in the packaging value chain, Heidelberg has joined the alliance last year. It is a platform for the whole industry to collaborate on the next level of circularity. The aim of the Forever Green Alliance is to raise the overall recycling rate of fiber-based packaging to 90% by 2030. So from 85 now to 90 by 2030. It focuses on European packaging systems, but always with an eye towards global applicability. It is a very active alliance, and there's a lot of going on. Recently, Forever Green has published a circularity by design guideline for fiber-based packaging. Here you can see it. It provides guidance on packaging and material design with a focus on the easiness of collection, sorting, and recycling. The aim is to explain how different components of fiber-based packaging affect the paper recycling process in standard recycling mills in order to provide design recommendations. And it is aimed at stakeholders along the entire packaging value chain, from brands and manufacturers of packaging, retailers, converters, whatever, packaging designers, so for everybody in the chain.
Amazing. So, as every carton is made to a certain specification to be fit for a certain product, a single carton will have its own carbon footprint. And setting off the carbon emissions of a packaging product is also a cost factor that brands have got to consider. What does this mean for packaging converters?
So what does it mean for packaging converters? For packaging converters or manufacturers, the ability to produce packaging with the smallest possible footprint, carbon footprint, is becoming an important success factor. The carbon footprint per ton of substrate or per carton during the production process needs to be continuously reduced. And this gets even more important when the digital product passport is introduced. It is part of the eco-design for sustainable products regulation and a key element of the Circular Economy Action Plan. It will provide transparency and give consumers easy access to information about the material it contains, such as recycled content or carbon footprint and recycling details. And most likely this is also applying to packaging. If we look at sustainable packaging production, let us have a look at 2 points. It's energy consumption and CO2 emissions. About 85 to 90% of the carbon dioxide emissions in printing come from cardboard used as printing stock. And that means that reducing board waste protects the environment. And it also saves carton costs. And for both, it is key to use state-of-the-art production technologies that consume as little energy as possible and save as much resources as possible. During our product development, these aspects are key. And we see more and more printers invest in machines that are CO2 compensated. Currently, we have compensated more than 830 machines in pre-press, press, and post-press. In total, 78,000 tons of CO2. That means, imagine, over 330,000 trees planted. And if we take a soccer field or football field with 300 trees planted, so it's 110,000 soccer fields of trees.
Wow, that's incredible.
Yeah.
So Matt, can you give some examples from Heidelberg? Is there anything more concrete that you can add to this?
Yes, of course, yeah. The main drive, for example, on a Speedmaster XL106 has an energy efficiency level of around 95%. And that's around 5% higher than a standard motor. So the new Speedmaster generation is around 41.7% more energy efficient than that of a 1990 equivalent press. So we also have lots of features within the machines, and far too many to describe individually, but we'll talk about a few. We have a standby function on our machine, for example, which saves around 3,600 kilowatts per year per print shop. So using this function for just 1 hour a day can give those savings, and this equates to an annual energy consumption of an average household, or just over 2,000 kilograms of CO2. And the function is automatic in many respects. It's a touch of a button, and thanks to the software in the machine starts up very rapidly. So it's a very simple operation, something that sits in the background almost, but gives a very high energy efficiency. So in terms of energy efficiency in Heidelberg equipment, we consistently drive our R&D departments, and that's not just from us as product guys. That is led by our customers, dealing with customers' requests. We then work that into our R&D efforts, and that translates into the products that we get today. So, for example, one of the key areas that we have is colour measurement and registration within a machine, what we would typically describe as a make-ready process. And today, with our new product, Impress Control 3, that pretty much automates the colour management and registration when making a job ready. So what that means is that we can run to a delta E value. These are all branded requirements from our customer's customer, the consumer, making sure that everything is perfectly okay. And we can run that to either a dot gain value or a delta E value. So I've put up an example from a 1990 press compared to a modern machine, for, if you like, a 2021 machine. And this is a real customer who have both vintages, should we say, of machines in their factory. And you can see that from the 1990 machine, the sheets per job in terms of waste is 383, whereas the modern machine, you can see at 2021, is just 260 sheets. So that saves just 123 sheets per job when making ready, which doesn't sound like a great deal, but when we consider that that particular customer does 6,500 jobs per year, you can see there that there's over 800,000 sheets saved. So when we consider how those sheets are produced, how they're shipped, how they go through the press, the electricity used and so on, you could imagine there's a huge saving in an environmental impact. And of course, there's always a saving in costs, which is down to the profits, if you like, of the customer. So in addition to waste material savings, Heidelberg have also created some state-of-the-art equipment for packaging converters in terms of hardware. And this is called high colour multi-drive. So historically, what would happen is you would go through a process of linear aspects on a printing machine. So you would have to stop and start as the machine, if you like, told you to do so. Whereas today we've automated and combined many of those functions together. And what that actually means is that rather than spending maybe 40 minutes or an hour preparing a job before we start printing, because we can layer multiple functions together, that can bring that production, that make-ready time, probably down 70%, which gives us more production time and less waste and less electricity and so on. So the increase in volume for packaging relates to the short-run aspect of what we're seeing in the market today. No longer do we see hundreds of thousands of sheets going through a press per job. In actual fact, the jobs that you have in front of us, the average run length of these jobs are around about 8,500 sheets.
So, modern printing presses are much more than heavy metal. Artificial intelligence, automation, software, robotics, and cloud computing is taking over more and more. How do you see this at Heidelberg?
I mean, for sure. In printing production, we see an increased use of robotics to improve precision and productivity and, of course, reduce time. While the use of automation and artificial intelligence help us to coordinate and optimise production and operation. And it increases efficiency, it reduces waste, and obviously that has a huge environmental impact. And of course, reducing waste, wash and solution and material, even in the printing process, has a knock-on effect. Heidelberg introduced an automated system which can determine the correct washing programme, for example. And it doesn't sound like much, but as historically a printer, I may have used the longest program with lots of wash solution and so on and so forth, creating VOCs and all that type of thing, because we did. That's how it was way back then, because the intelligence wasn't there. Whereas today, what happens is the machines can automatically determine from the material that you're printing, whether that's an uncoated substrate or a coated substrate, how many sheets we're actually printing and how much ink volume we're putting onto those sheets, which all comes from our workflow. The machine will calculate both the shortest wash with the least amount of solvent being used. So again, a very efficient process within the printing process. We have other software products which were introduced into our machines a couple of years ago, device assistants. So this links in some of the hardware that we have on a printing machine into the central nervous system of the machine, which means it stops me from having, let's call it human errors. If I was to run out of something on the machine, say for example when I was coating a job and my coating barrel ran out because I was talking to somebody or doing something different, then theoretically that machine would have carried on printing, the product would have been waste and we would have had to throw it away, and of course that gives us more problems in terms of more material and more waste and so on. So today, Device Assistant allows us to connect our coating systems to the press, so should that coating run out, the machine understands that it's run out and will automatically stop the feeder of the press so that we don't run waste. So all of these things now are being developed year on year to try and reduce waste within the printing process. So there are many other assistants connected to the devices to find fault detection, but again, far too many of them to go through individually in a conversation like this.
Thanks, Matt. That sounds really interesting. But what I'd like to find out a bit more is, what about Postpress?
Okay. Yeah, if we look further on the automation of folding carton production process, the main reason for automation are, of course, the reduction of labor costs, or when operators cannot keep up with the volume and complexity of the tasks. And automation not only supports operator, but also help make processes more efficient. And we saw, and thank you, Matt, press operation is already largely autonomous, and intelligent systems, we use intelligent systems there. There's also fully automatic logistics systems at the feeder and delivery, and that enable non-stop production. With some companies are also using AGVs, automated guided vehicles. Yeah, exactly. So, but Postpress still has to catch up. There's something to do. However, even though the level of automation has increased significantly in the recent years. For example, more automatic setting options have been added to the die cutters and folder gluers. Also, we see more and more of our die cutters with elevation in the equipment. An example is our new performance die cutter, the Master Matrix. It is highly automated with many presetting functions and quick lock devices. It is connected to the workflow and gets presetting data. The feeder sets automatically. This saves a lot of time, and in addition, this cutter also has tool compatibility with existing competitive equipment, something which our customers request. And when developing our new products, of course, we take it, we use it, and we deliver to our customers. And it has no negative impact on the environment with new cutting forms, so no new materials, transportations, and so on. And just to say, after successful beta test, within half a year, we have already installed 4 machines in UK and Ireland, one at a well-known international folding carton group with high demands on performance and productivity. So die cutters are also integrated into intralogistic, that means the internal logistic in the production, and meaning that non-stop operation is possible here, while on folder gluers, robots automate the process of feeding the folding carton blanks and palletizing the shipping cartons. One of our latest product additions is a feeding or a blank feeding robot on the folder gluer. This is particularly efficient in 3-shift operation for long runs and for heavy carton blanks. We have carried out first installations in Central Europe, or a first installation in Central Europe, and already have several inquiries and planning in process.
And what about AI and cloud computing? What does this mean and what do you have at Heidelberg?
Well, so far we've been talking about a single print shop in isolation, but it's also important for the printers to know where they stand in the bigger picture. So, for instance, how does their performance compare to that of their competitors, for example? In which areas can they or must they do better? And how does big data and artificial intelligence come into play? It means that our learning base has expanded enormously. It's no longer limited to individual presses or the interaction between machines in the press room. This information, of course, is anonymous. If I'm comparing myself to my competitor, I don't know the names of those people. I'm just given an indication, really, to see how I'm performing against a market. So I just point that out because of data protection. But when it comes to the actual press itself, our customers require, LAB values being directly inputted into the machine, or CFX data directly inputted into the machine. And that is all done directly from our colour management system. So it gives the brand owner a perfect reproduction of the colours that they've always had previously. So, for example, we have around 13,000, probably 13,500 machines connected to the Heidelberg cloud. So data from over 60 million print jobs, per week, incredible numbers. So that contains a huge amount of knowledge for us, and the artificial intelligence that we can use that data to design the technology for the future. So we provide this information for performance benchmarking with a product which we call Heidelberg Assistant, which is a customer portal, giving them all of the information required for them on their equipment. In terms of what jobs they print, how they print them, whether the jobs run well, whether the material's good, whether it's bad, service calls and so on. It's all in one place. So we're using artificial intelligence to automate consulting services. Here at Heidelberg, for example, we have PAT, which stands for Performance Advisor Technology. So PAT is an AI module that we have installed in the cloud that custom evaluates data from all of the connected machines. So it uses a pool of rules created by experts to highlight those anomalies that I've just mentioned. Heidelberg Assistant then makes the customer aware by displaying an incident or a recommendation. It might be that we think that somebody may need training on a certain area of a product, by benchmarking, by the analysis that does so to keep the productivity high and to keep the waste low. So we're using feedback from the customer to create a feedback loop. The information we get from the customer adds to our data, and by using this information and comparing patterns, PAT is learning all of the time, hence the AI, and all on an autonomous basis by using artificial intelligence. So, in fact, our machines, our presses, will automatically email our central service station here in HUK or Heidelberg UK if we have an electrical fault, for example. So our customers get a consistent production level. We know if and when something is or potentially could fail. I'm not suggesting it does, but if that was to occur, we can identify that, get parts shipped prior to the failure. So again, they're not waiting for 24 hours for a part to be shipped. So our customer service levels are very high. 75% of our problems are identified with equipment prior to arriving at customers. And of course, 20 years ago, that would have involved somebody jumping into a car, driving to the customer site. So we talk about our environment. We're reducing the usage of fuel. It's a very hot topic at the moment, but also reducing costs generally from our customers and ourselves, and keeping productivity levels high. And we really do believe that AI boosts the customer productivity, and they can make their whole business more efficient and cost effective and more sustainable. And of course they need to reduce the use of energy, their resources, their materials, consumables, and of course reduce the carbon footprint to the benefit of the environment.
And where do you see the current challenges and how is Heidelberg meeting them?
So a major challenge is certainly the current supply situation. There's a shortage of paper and board, both, and also the delivery of some machines, or the delivery times of some machines, are getting longer and longer because there is some, obviously something going on in supply chains. But with our partner MK Masterwork, especially in Postpress, we see now MK Masterwork is still able to meet reasonable delivery times for die cutters and folder gluers. They have invested heavily in a new modern factory and increased production capacity, and that is paying off now. So another thing is the labor shortage. At least in Germany, we see it's massive. It's massive, especially in packaging printing, and it will increase even further. So tougher legal requirements and documentation obligations for packaging are also increasing the demand for skilled staff. And besides packaging production as such, this is also affecting businesses such as manufacturer of branded goods or packaging machinery. They also need these skilled people. The competition for suitable recruits is becoming fiercer, and we are constantly increasing our training offerings and online training tools to support our customers. And what we see, younger generations in particular place great value on attractive workplaces. They want smart digital tools that are easy to operate, and they want to have fun to work with. So the latest technology such as touchscreen, machine operation, and AI-controlled apps is therefore a must. What we see, and this aspect is also playing a key role in the development of our products, of course.
Thank you, Kerstin. So, Matt, what about the importance of software?
Absolutely, software is all around us, right? So the software landscape at Heidelberg or at packaging suppliers is very fragmented. There are lots of systems which have been designed in-house. They don't necessarily talk to each other. So again, the efficiency of those products greatly need to be improved. So there's a wide variety of different options in the market, from MIS, pre-press, planning software to analysis programs. And data collection sometimes is still done manually at the equipment in some of those companies. So it is down to the human to put that data in correctly or incorrectly. So open interfaces are very, very necessary, and network machines from different vendors are still in short supply. So we've recently started a cooperation with ESCO Graphics. Via that interface, we're getting even more information for our pre-press production workflows and the software for a product that we have, which is called Production Manager. And we've already started lots of working partnerships with companies which are very established in software in the packaging environment. So in our print media center, or as we call it, a showroom, in Wiesloch-Walldorf in Germany, clients can test run our equipment from workflow, press, post-press, data collection, and all of the way around the entire production flow. And we do individual demos for potential customers. We invite them to bring their jobs, not stock jobs that we may print, but many of the jobs you see in front of us that we wouldn't be familiar with. We invite customers to bring these jobs in so that they can see for themselves the efficiency, if you like, from the equipment that we have, to prove that we use half of the waste that you would use compared to an older vintage machine. And we also do that as part of an investment calculation, so we can do a whole life cost of the equipment from end to end, including services such as an equipment as a service, which is becoming more and more popular from many of our customers as well. So it's interesting to see how this develops, and of course we'll play you a video just so you can see our packaging showroom in Germany, and of course please contact either Kerstin
please,
or myself if anybody wants to know any more details about anything that we spoke about.
Brilliant, thank you so much. That concludes our webcast for today, but we have got a Q&A box, so any questions please pop them through and we'll be answering them shortly.
Thank you very much.
Thank you.
Hi there, Kerstin.
Hello, Matt. So I think we got some questions. Thanks everybody for taking part. So shall we have a look?
Yeah, let's go.
What came in? Let me see. There's one, I think, on the design guideline from Forever Green. Does it say something about the recyclability of metallic decoration elements? Yes, it does. It does for sure. It says that hot and cold transfer is fully recyclable in the standard recycling mill process, whereas it is difficult to recycle PE or PET laminated material. And it also recommended to use, to reduce the surface of metallization during the design stage. It is mainly due to the detection of the material. So the more metallized, elements or spaces on the packaging, the harder it is to detect it in the sorting process and to bring it to the right recycling stream. So it is recommended to use not fully cover the packaging with metallized effects. I know it's for the designers it might be hard because of course it's nice to have metallization on the packaging, but that's what they say what is said in the guideline. And I can add, we see at Heidelberg also that there is an increase in the demand or the requests for cold transfer systems that we can put on the press. So it's certainly something that is going on. But there is, it says something about the recyclability.
Okay. We have another question here. Would it be possible to have a description of the hybrid printing process, advantage on reduced use of plates and cylinders? And would that be measurable or reduce CO2 footprint? So if I understand the question correctly, Alinto, the hybrid printing process generally is either a mixed operation, so a mixed operation between conventional printing or UV printing, which is very straightforward. The majority of customers, certainly in the food markets, are using low migration inks. There was another question linked to this as well, actually. And the use of low migration, should we say consumables, is very popular, very established, been using that now for a good 10 or 15 years. Another question that was asked was, can the machines perform at high speed? And the answer is yes. We've got customers who are producing UV in conjunction with zero alcohol and running maximum speeds, making ready maximum speeds. Sorry, Alinto, you've put, is it offset and rotogravure? It's offset in the conversation that we're having here today, we're sheet-fed litho at the moment. So yes, those reductions of CO2 can be done from a machine point of view, because we take the conception of the machine to the delivery of the machine, and then we calculate all of the CO2 and therefore the offsetting of that as well. Thank you, Alinto. Kerstin?
I check the questions. What is it, the sustainability status and feedback on the use of UV inks and UEB varnishes and so on? Is there any documentation you can share? Yes, it also goes back to the design guideline, because it also includes UV inks, so every type of varnish, inks, adhesives, binders, gluers, and so on. It goes back to the recyclability. If it's recyclable, sorry. But of course, all these materials are constantly watched for reduction on health, or reduction on health risk, and so on. So we will use, of course, non-risky materials for this type of inks. But I can share the link to the documentation to the circularity by design guideline for Evergreen.
We have a question from Kit. I see the make-ready times are much shorter on the new XL106 packaging machines. Why is this, and what is different from the 1990 machine? So the short video which we played was an example of an XL106, and what happens on a modern machine, for example, with the high colour multi-drive, which we showed in the video, it means that if you were using, say, an 8 or a 10 or a 6 colour press, but you were only using 70% of those printing units, you're actually able to wash the 30% of the units whilst the machine is actually in production. So you could wash the rollers when the machine was in production, for example. So if you look at a 1990 machine, you'd have to stop, wash those 3 printing units using the whole main drive, all of the energy for the machine to wash the whole, to just wash 3 units, you'd be using the energy of all the machine. Whereas on a modern machine, whilst the machine is printing, you're able then to intelligently engage a wash program into the rollers. So that clearly saves time. What would have taken 20 minutes would be hidden now, if you like, in the job. Plus, we can change printing plates, clean blankets, wash rollers, all at the same time. Whereas on a 1990 machine, that would have been somewhat linear. You would have changed the plates, then you would have cleaned the rollers, for example, and then you may have done it again. So that's why the make-ready time, because that's what we would include, everything from the last sellable sheet to the next sellable sheet, the make-ready time has been dramatically reduced by up to 70%. Hopefully that answers your question, Kim. Thank you.
So, what else do we have? I need to put it in the chat. So there's a question from Olinto. Would it be possible to have? No, this is something already. Also from Olinto. Is there any coating material that could increase O2 barriers on PE or PE 100% monomer material structure, avoiding the use of metallized layers? No, this is, I mean, not to my knowledge, sorry to say that, but not to my knowledge. This is a hard one. We are working on barriers to replace plastic material on board with barrier coatings, but at the moment there is a lot of going on in this area, but there is, it has to find the right formulation of the coatings and also the right thickness to bring it on the board, and it has some limitations at the moment, but all the industry and the stakeholders are working constantly on that to reduce plastic or aluminium and replace it with barrier coating, but yeah, it's not to my knowledge, it's not possible at the moment.
Okay, I think we'll give it a few minutes to see if there's any more questions come in. Quite a complex subject, Kerstin, overall in packaging, of course. I did see, I'm sorry, I'm just going to flick through the chat here. I think
there was something with elevation.
Yeah, something to do with that. Yeah, there was a question about elevation in...
Maybe you want to take that, or shall I take that? I don't know.
I don't mind. I mean, I'll have a quick look at this. Just got to find it. I'm sorry, there's lots and lots of questions in there. Here we go. Oh, it was in relation, Kerstin, to die cutters, and it was Chris asked why is it that there is an increase in elevation? So why are the machines higher nowadays on die cutters compared to years ago?
Yes, okay. Mainly in the past, it was due to some, let's say, cost reasons. But the elevation gives a lot of benefit, not only at the die cutter, of course, also. With elevation, it is possible to run higher pellets with more sheets, and especially with cardboard. Cardboard is a thicker material, so normally you have less sheets on the pellet, and you need more pellets. But with an elevation, of course, you reduce again the amount of pellets on the floor. And in addition, pellet changes are much smoother. So the less pellet changes you have, the better it is for the production run, and the smoother the production is. So it has two things: smoother production run and less pellets on the floor. And yeah, we normally recommend for the thick cardboard material, we recommend elevation on the press and on the back. Is that correct, Matt?
That's correct, Kerstin. From my side, yeah, definitely.
Good.
Less pile. I mean, on a press, obviously, less pile turning when the materials come in. Better purchasing power for when you're shipping the product, because you can get more into containers and so on. So these are some of the hidden advantages you see. Not necessarily at the press, but of course some of those advantages, benefits for a customer around the machine. I've got a question here from Dario. Is it possible to disengage printing units to save energy? We disengage printing units on the machines that we showed you here with high colour multi-drive if we're not using them. That's correct. So yes, we can is the answer. But in addition, there are sometimes some risks when disengaging a printing unit if you're not using it, because the rollers may stay in, well, they will stay in contact. So if you disengage the printing unit for a day, 2 days, if you had a huge job on, when you come to start the machine up again, the contact of the rollers have, because of the washers that are concerned usually, could have a tearing effect on the rollers, leaving a stripe or damage on the rollers. So our system in high colour multi-drive, rather than just disengaging them and leaving them stationary, what will happen on a set time period, without us even seeing it or knowing it, the machine will automatically it will move the rollers around a set distance, so that the problem I just described, where they sit together and potentially damage themselves, does not happen on our equipment. This is the R&D guys being smarter and smarter each year. So I think, unless there's any other questions, I think that concludes our conversation. Of course, our email addresses are on there, should anybody have any further questions or think of something afterwards. Yeah, I think we're okay there. Let's see. Oh, we've got one last one coming in. Okay, so Louise asked how.
Yes, I need to give me a minute to send the link for the design guideline. Then I put it in the chat. It can be downloaded only for Evergreen. Here's the link to the design guideline. So it's free. It's downloadable at the for Evergreen website.
Great, super. Okay, great. I think that concludes our conversation with sustainability and automation. Thank you very much for taking the time to sit through this with us. One last question. Oh, here we go. Thank you. Thank you very much, everybody.
Thank you very much for taking part, for being our guest. Thank you.